So we were looking at a reachability matrix, a two-step reachability matrix over here, and how it related to this diagram. Now the idea here was this 2 represents the fact that we can reach B from C. So from C we reach out towards B. So B has been reached from C in 2 steps, 2 different ways. Let's have a look at how that is the case. So we're reaching from C, okay, towards B, and that's one of the ways, and we can reach from C to B another way. So in our 2-step reachability matrix we put a number 2 showing that we can reach from C to B. Remember, B is being reached. Reachabilities are based on the columns here. Now it's interesting that rather than having to work out all the 2-step reachabilities, there's a much easier way of doing this. We can actually take the 1-step reachability matrix here and square it. And we can put that into our calculator and square the matrix. And likewise we can do that for a 3-step reachability as well. And that will provide the correct number of reachabilities, etc. in this matrix. The only problem is that sometimes the calculator will produce numbers in this leading diagonal. Now, if you think about what this leading diagonal means, for example, this first element here, that's suggesting that A can reach itself. A can reach out to itself, which would represent a loop. Now you can see that there are no loops in this diagram, so that would not make sense. Okay, so if that happens, if you use your calculator to get a 2-step reachability matrix, or even a 3-step reachability matrix, just check that leading diagonal and change any numbers into zeros. Okay. Now, dominance and reachability are really 2 sides of the one coin. Look, if an edge in a directed network moves from A to B, then it's said that A is dominant or has greater influence over B. So if we look at the results of a round-robin tennis competition down here, one of the things we notice is that C is dominant over A. And likewise, that means A is reachable from C. So dominance and reachability are really just the same thing but from a different perspective. Dominance from the perspective of C, dominating A. Reachability from A's perspective, because C is reaching out to it. So in this example we're going to look at how we can determine the dominant vertex. So we can see that A beats one of the others. Who is that? A defeats B. And we can see that B beats nobody. If you look at B, there are no arrows leaving B. So all the arrows are incoming towards B. It's being defeated by everybody. If we look at C, C beats 2 of the others. Who are they? Let's have a look. We've got C defeats B and C defeats A. So C beats 2, or is dominant over 2. D beats all 3 players. You can see that D can beat A. It can also beat or dominate B, and D can defeat or dominate C. So that means D is the dominant vertex. So we can now rank them in order. So we've got in first place D, because it can beat all 3, second place C, third place A, and fourth place B. Now obtaining that ranking was done just using one-step dominances. If we want a little bit more information, we might take into account the two-step dominances. So it's a bit like saying that Essendon can defeat Carlton, but as a two-step dominance, we might say that Carlton can defeat Collingwood and Collingwood can defeat Essendon. So in a way, in two steps, we could say, well, Carlton should be able to beat Essendon because they can beat Collingwood and Collingwood can beat Essendon. And I know that's contradictory, that it looks like, because Carlton obviously didn't directly defeat Essendon, but indirectly it had a two-step dominance. But if we take into account this second level of dominance, it can give us a little bit more information. So let's have a look at an example. We've got our two-step dominance matrices here for the situation above, actually. And what we're going to do is add our two-step dominance matrices together, and we get an overall matrix, which is this one here. Now, whereas before with reachability we added up the columns, with dominance we're adding up the rows, because what this is saying here is that A is dominant over B, and here C is dominant over A and over B. And this is again taking into account the one and two step dominances. Alright, so in that way we can get a ranking. It's a bit like using a points system, say in horse racing, where you were rating horses and you said a horse that's won a race will give that 3 points, a horse that's run second will give it 2 points, and a horse that's run third will give it 1 point. So what we're really doing here is just adding up the points for A. Points for A total is 1, B has a total of 0, C has a total of 3, and D has a total of 6. So we would rank D in first position. Okay, and then we would rank C in second position, and this should say A in third position, so we'll need to correct that, and then B in fourth position, so just be aware of that error. So overall, to determine dominance, we add each row. And I think we'll just leave it there.